Hi everyone. Finally, after years of being away in another country pursuing my master's degree in electrical engineering, I am finally back with another video. In this video I am going to talk about the most controversial motor design that has shocked the entire automotive industry and have countless YouTube channels talking about it. Yes, I am talking about the Koenigsegg dark matter motor. This motor in specific boasts a high power packed inside a very small package, and today we are going to reveal the internals of the motor and try to do a study on how the motor is built. Let's dive into it. This is the official website of the Koenigsegg company flaunting the dark matter motor. Looks great and the figures are just too good to be true. Packing a 800 horsepower 1250 Newton meters at 9,000 revolutions per minute in a package that has dimensions almost as big as a football and weighs only 40 kilograms. In this video I'll show how exactly the internal structure of the motor should look like to fit a radial and axial stator. Before diving into the design, a clear difference between a radial and axial flux is as shown. The magnetic field traveling radially outward from the axis of rotation is a radial flux motor, while when the magnetic flux travels parallel to the axis of rotation, it's called the axial flux motor design. Now, here is the similar version of the motor that I have designed with respect to the Koenigsegg dark matter motor, which combines the radial and axial flux stators. Quite similar, the dark matter motor, the cutout and screw mounts as highlighted here shows exactly where the axial flux stator cores, pole pieces are mounted. This mounting method makes it very clear that it has axial flux stator on both sides and each side has 12 stator poles. To make it slightly different I have designed it to have 18 instead. Now that we know that the stator poles are 12 and that must also be the same with the radial flux one, we can come to a conclusion with respect to the 2:3 ratios in motor design. The rotor magnet poles must be a multiple of 3 and an even number, obviously to correctly match with the step angle of the 12 pole design. And thus we can say that turns out to be 18 magnet poles. The only difference in my design is that I have switched the stator poles and rotor poles 12 and 18, to 18 and 12, while keeping the design language same. Finally, let's check out the rotor design. The 12 magnet poles are placed so that like poles are facing each other, which creates a repulsive magnetic force which pushes the magnetic field outwards. Now note that the forces being pushed outward isn't just radially outward but also axially outward. The rotor disc here is made up of steel and has slots to accommodate magnets. Notice that the slots have a slope to allow the magnetic field to exit out from 3 surfaces. That is 2 on either sides axially outwards and 1 on the top going radially outward. Thus just one simple rotor in between 3 stator is the key to have an absolutely powerful motor. Here are the 3 stators highlighted in blue, one by one displaying position along with the rotor. Now one of the major question is how to combine the power of all the 3 stators in one. And the answer is to merge the power of 2 different types of stators powered by 2 different 3-phase inputs, making it a 6-phase motor. This power needs to be smartly combined to add it up to the torque and speed to have a really powerful motor. There is no point if the 2 stator magnetic fields try to oppose each other mechanical forces, as it will only cancel out the forces resulting in stall, or even worse, will burn the machine. Thus, to have the force added up, the radial flux stator poles must have a 10-degree offset with the axial flux stator poles. Note that this angle will be 15 for the 12-pole design used by Koenigsegg. This offset allows a seamless magnetic field flow which loops back into rotor through both the stators. This offset is the key component which helps combine power. And finally, to check the dimensions of my build, here are the figures: 190 mm diameter and a thickness of 152 mm. This is a similar specification to that displayed by Koenigsegg but with 18 stator poles. Now, as all the designed parts are assigned with their respective materials, that is laminated steel for the core, copper for the coil, aluminum or carbon fiber for the outer case, solid steel for the rotor disc and steel for the magnets, and so on, the total weight of the design gets close to 71 kilos. Now this figure is impressive as this design has not gone through iterations for weight reduction, but surely has a possibility to go to a lower weight like 40 kilo. Maybe after changing it to 12 stator pole design. Or some other dark magic, I guess.
Finally, if you like this video content, please make sure you like and subscribe to the channel for further videos. Please contact me on the email ID given below if you wish to seek any support for your projects. And I will see you in the next video.